talk about functions and relations, we're actually talking about the types of equations you've been dealing with pretty much all the equations you've always dealt with. It says a relation is defined to be any set of ordered pairs. So you've heard me say that it's not coincidence that we have an x-coordinate and a y-coordinate, an x-axis and a y-axis. And when we graph a line on here, that line represents a relation. It's a relation of all the solutions to an equation. So when we have the point 3, 2, that's relation. When we input our 3 into some equation, we get out our 2. Okay, so there's a relationship between the 3 and 2. Now a function is a specific type of relationship. Okay, right here it's a relationship between the input and output. And I've already been referring to our x and y coordinates as the input and the y is our output. So a function is just a specific type of relation that follows this rule right here. For each input there is exactly one output. Exactly one. So if I input this 3, I only get out a 2. If I input, I don't know, a -4, I only get out a 6. Okay? So for each input there is exactly one output. Now, if you think of all, or for most of the equations we've been graphing, they've been straight lines. And so if I pick this point, let's say right here, let's say this is the point 2, 1. That means when I inputted this 2 into whatever equation this graph represents, I got out a 1. Okay, so there's a relationship between the 2 and the 1. The 1 is dependent on whatever input we do, the 2 we put in. Okay, so a function is nothing different than the equation we've been dealing with. It's a relation that for each input there is exactly one output. Now, these are called mapping diagrams, and it says here, decide whether the relation shown, is a function. If it is, give the domain and range. Alright, so let's talk about a couple of things here. Look at our inputs. If I input this 4, it has arrows going to the 0 and the 1. That means if I input a 4, I get out a 0 and a 1. If I input a 6, I get out a 4. If I input an 8, I get out a 4. So if we were to draw these as ordered pairs, this would be the ordered pair: input 4, output 0, input 4, output 1, input 6, output 4, input 8, output 4. Now, it does want to know whether this is a function. Remember, to be a function, for every input there is exactly one output. So if I input a 4, what do I get out? Do I get one output? No, if I'm looking here, I get 2. Okay. That's still a relation, but it's not a function, because if I input 4, I always think of it as inputting into a calculator. If I input a 4 into equation in a calculator, the calculator doesn't show me an answer of 0 and then flash and give me an answer 1. It gives me one answer. So this is not a function. It's not a function because when we input a 4, we get out a 0 and a 1. For every input, for every 4, there has to be exactly one output, not 2. Let's talk real quick about the 6 and the 8 here. They both go to the 4, but that's okay for it to be a function. If I input a 6, I get out a 4. Again, think of a calculator. If you input 6 into a calculator, and the calculator, into your equation, into your function, and it gives you a 4, that's okay. If you input 8 into the same function, to the same equation, you get out 4, that's okay. Because for every input, there's one output. But an input can't have 2 outputs. Look at this example here. If I input 1, I get 2 out. If I input 3, I get 4 out. If I input 5, I get 4 out. If I input 7, I get 6 out. Notice for every input, there is exactly one output. Yes, our output might be the same, but one input has one output. Okay, again, this would be the ordered pair 1, 2, 3, 4, 5, 4, and 7, 6. Not that you have to make these ordered pairs, but sometimes it's nicer to see them, or see the function. Okay, so again, yes, these both go to 4, but every input has exactly one arrow off of it, so that's why this is a function. Now the second part here says, give the domain and the range. Now your domain is the set of all inputs. Your range is the set of all the outputs. When we write these, and I spell them correctly, you write them without repeats and in order. Okay? So it says if it's a function, give the domain and range. Well, the domain for this function here is just 1, 3, 5, and 7. It's just all of our inputs. Our range is just all of our outputs. 2, 4, and 6. That's it. Okay, now I know the word range can get confusing because we also have range for mean, median, mode, and range, but this is a different range. Okay, our domain is a set of all the inputs, or our x values. The range is a set of all the outputs, or our y values. And again, you write them in order from least to greatest, and if there was a repeat somewhere, you wouldn't write the repeat down here. So if 3 was repeated twice here, you would only write 1, 3. Okay? So function, again, for every input, there is exactly one output. Domain and range. Domain is the set of all the inputs, and range is the set of all the outputs.